we are studying the event regions, because event regions are related to your execution orders. So your first is your execution order must be there, because it is your hardware language. It can run parallel, sometimes it can run sequential, sometimes not, like your programming language. So some order execution must be there, that it compiler doesn't get confused. So first of all, this thing is related to compiler, you can say, because every coding language depends on compiler. So you can say the execution order should be defined, and avoid race around condition, because you are defining hardware. So for example, if you are defining latches, so it should not have your race around condition for that. So synthesis should be proper. This will be your separate video. After this video, I will create this video for blocking, non-blocking. So before that, I am completing your event region. So this is a very important topic. And next is your model hardware behavior. As I said earlier, the hardware behavior should be mimic your exact behavior of your hardware. So we need some execution order for that. Synchronization of DOT and testbench, because DOT and testbench are synchronized with single clock, and there are some regions and there are some directions between DOT and testbench. So some synchronization need between your DOT and testbench, how they both will execute. And enable verification features. So we have some features in SV. We will see this whole part is our assertion, coverage, and clocking blocks. So for that, we will see our Verilog, and you will know this. Support 0 to 0, we will know this after 2 slides. And provide multiple hooks. Testbench can drive and react correct line times without correcting the duty, because they both are executed simultaneously. There should be some specific order for execution, so it cannot interfere with your duty. So important points are your blocking, non-blocking. We are studying for that, and avoid race around condition. Defining some execution order. There should be some specific order or rules for execution, and these are our SV concepts, which are most important for our verification. Without this, we cannot verify anything. So let's see without any delay. So as you can understand this with you can understand, like, there is passage of clock and we are executing some signals. So some will execute in this part, some will execute in this part, some will execute in this. So we are dividing some slots, that at which slot the some execution statements will execute. So simple logic is there, that we have defined some execution regions, which we are saying event regions, and divided into ordered regions, as you can see here, divided into some ordered regions. So we will know that at what time it will execute, and it will not interfere with other. Simple logic. And now logic is that this block will start, and after all completion region, we will go for our next block. So between them there are 4 regions: active region, inactive region, enemy region, and monitor region or postponed region. Mostly we will call this a monitor region in Verilog. And before that also there is postponed region, but mostly we don't consider it. We directly say that there are only 4 regions. So only stick to your 4 regions. If someone asks you that there is postponed region, you can say there is, but it has no importance in for now. So these 4 regions we need, that active region, inactive region, NB region, or postponed region. And we will see these regions one by one. So we will only understand that what execution statements are or blocks are executed in specific regions, and this is all our concept about event region. Simple concepts. Our initial block, always block, and with that module, program block, all these block execute in our